prediction aim to determine the future movement of a stock value of a financial exchange. The accurate prediction of a share price movement will lead to more profit investors can make. Unfortunately, this is impossible because no one knows the future. However, we can make estimated guesses and informed forecasts based on the informations we have in the present and in the past regarding any stock. So, our goal in this project is to read and analyze the data using some AI techniques and present some valuable information for the traders.
For our project, we decided to do stock market prediction. The stock that we chose to predict was the SPY stock. SPY is an exchange-traded fund that owns all the stocks in the Standard & Poor's 500 index. The S&P 500 is arguably the most important market measure used by investors and traders around the world, as it's the benchmark for trillions of dollars of investment. The main way that this project was completed was through the use of an LSTM. Large Short-Term Memory, or LSTM, is an artificial recurrent neural network architecture used in the field of deep learning. LSTM networks are well suited to classifying, processing, and making predictions based on time series data, since there can be lags of unknown duration between important events in a time series. After we run this project, which I already did to save time, you will see these graphs pop up. In the first graph, we are able to just visualize our data being trained, and as you can see on the y-axis, we have loss compared to epochs on the x-axis. An epoch is just a period of time, and as the lines converge, that means that it succeeded and for the most part is accurate. In the second graph, we are able to look at accuracy versus value accuracy, and an important thing to note about this is that we are trying to look for the two lines to either align or converge as the number of epochs increases. If the lines do not end up converging, then this means that our model is inadequate and we would have to go back and modify some of the necessary parameters. In the next graph that should pop up soon, we were able to plot the predicted values compared with the actual values of the stock data we gathered. The way to read this graph is to look at how close the two different values are. If the predicted values are nowhere near the actual values, then we can infer that our model is not efficient, and if the values are closer together, like in our example, then we can confer that our data is acceptable. In the fourth and final graph, we were able to show some rather interesting data. The blue data is all of the previous data that we gathered, and it's the actual prices, and the red data is forecasted future predicted data. So one interesting thing about this is predicting stocks is very tough, it's very volatile, and there are so many factors that can change a stock's price. There was a story of a competition in Britain a couple years ago where they had a cat and professional stock traders, and the cat randomly chose stocks versus the professional stock traders actually using logic, or at least trying to use logic, and the cat chose the better stock and ended up making a lot more money. The stock market is just one of the hardest things to predict, and it very well might never be predicted to the ability that someone would want to try and make money off of.